And section 11.3 looks more at some geometry, looking specifically in this section at hyperbolas. So I gave you a couple of different variations here. We're not talking about rotated hyperbolas, just basic hyperbolas where you can see these guys are centered at the origin and they're either horizontal, this guy has X intercepts, or vertical, this guy has Y intercepts. Okay, so let me see. Let me write that down. So this guy, we would call this one horizontal. And you can see that guy has intercepts on the x-axis versus this guy, we'd call it vertical. Guy has intercepts on the y-axis. Okay, so I wrote out the equations. Now, I mean, I made a mistake in this one. We can look at the difference when we get to the examples, but they're really the same equation. The only thing that's different is which variable has the positive coefficient, like which is the leading variable. Like you can see for the horizontal hyperbola, the x has the positive coefficient. For the vertical, the y has the positive coefficient. We can see why that means the hyperbola is vertical versus horizontal, etc. when we look at the example. So find the vertices, foci, and asymptotes. So let me start with finding the intercepts. So those would be the vertices. So vertices, that means find the intercepts. Okay, so if I set x equal to 0, I'm looking for the y-intercepts. So then I'd have y squared over 9 equals 1, because this term would zero out. Y squared equals 9, so y equals plus or minus 3. So my vertices would just be 0 plus or minus 3. So actually, just with that information, I can tell you, since I have y-intercepts, I'm dealing with a vertical hyperbola. Because look at what happens when I set y equal to 0, thinking in terms of finding the x-intercepts. Okay, when I go back to my equation here, look at what is going to happen. If I set y to 0, I'm left with the second term, which is negative. I multiply both sides by negative 16, so there are no real solutions. So no x-intercepts. So because of that negative sign in the equation of a hyperbola, I'm only going to have x-intercepts or y-intercepts. I'm not going to have both. So that's what determines which type of hyperbola that I'm dealing with. So in this case, I could tell you immediately, because the y has the positive coefficient, this is a vertical hyperbola. And then look, I found the vertices. Those are the intercepts. In this case, they're y-intercepts. So what's left? The foci and the asymptotes. So let me start a sketch. Need some more room here. So if I start a sketch, say over here, set up a coordinate plane, x and y. Okay, so my y-intercepts, 0, 3, and 0, negative 3. So, a couple other things. So, hyperbolas have focus points. So these guys, these are focus points. They're always inside the hyperbola. So depending on which type of hyperbola I have, I know which axis they're going to be on. So for example, I mean, I know my focus points are going to be here and here, say, because I can tell you kind of what this is going to look like. We have a focus point here and here, say. But I have to figure out exactly, deleted my axis, exactly what those focus points are. And we have an equation for that. Okay. So the focus points can use this equation. So look at the equations of the hyperbolas in general. So just thinking about the m and the n as the numbers underneath the variables. Okay, so I can use the equation f squared equals m squared plus n squared to find the foci, focus points. So look at my equation. So I'm using these numbers. 9 plus 16. Square root of 25. And then those are on the same axis, of course, as the vertices. So in the region we were expecting. And then what else? So actually, hyperbolas have asymptotes. So for the simple hyperbolas that we're dealing with, the asymptotes will go right through the origin. And those asymptotes are what is going to determine how steep the hyperbola is. Because really roughly, let's see, if I have asymptotes like this, then my hyperbola is like so, right? Versus if I have asymptotes like way down here, my hyperbola is like really wide. Okay, so depending on those asymptotes, that's what tells me how wide or how narrow that hyperbola is. So let's see how we can find those. So actually, again, I'm using the numbers here underneath the variables. So you see how, I already used the 3. That's what told me the intercepts, right? I haven't used the 16, which gives me a 4, right? Because I look at the square roots of these numbers. So the 9, I took the square root of that. That gave me the intercepts. So look at this. Here's what I'm going to do. I'm going to say, okay, so I go up and down by 3 using the number underneath the y, the square root of that. So I'm here, here, and here. Then I'm going to use this number. So the square root of 16 is 4. Now I go left and right by 4. But these are not intercepts. I'm going to use these to draw in my box that's going to actually give me my asymptotes. So one more time, what did I do to get this box? I looked at the equation, I looked at the numbers underneath the variables. So the square root of 9 gives me my 3s, those are my intercepts. My square root of 16 gives me 4s, those are not intercepts, but I still use those to draw the box. Okay, so then I just go ahead and I draw the asymptotes right through the corners of the box. And it turns out, geometrically, that's where those asymptotes lie. We're not going too much into the geometry in this class. More just how do you come up with the sketch. You may have looked at the geometry in more detail in high school. It's interesting, but not as useful for calculus as the sketch is. So then I can go ahead and draw in my hyperbola, but maybe I should label my asymptotes first. So this is going to be y equals, what is the slope? The rise is 3, the run is 4. So isn't this just 3/4 x plus 0, right? Because the y-intercept is 0. This one would be the same, but negative. Negative 3, 1, 2, 3, 4. Got both the asymptotes labeled. So if you wanted to, when you're listing the asymptotes, you could do that concisely by saying plus or minus 3/4 x. And now I'm going to draw in my hyperbola. Okay, so let's use this color. So I start at the intercept, and then I have to approach the asymptote. So this hyperbola is pretty wide. Something like that. It's supposed to look symmetric, of course, but that looks pretty good. Okay, what is next? So here's another one. So in order to really read off the information, I would start by putting this in standard form. In other words, getting a 1 on the right side. So I would divide everything by 36. So 9 over 36 leaves me a 4 in the bottom. 4 over 36 leaves me a 9 in the bottom. And then I could probably start a sketch even. I can really read a lot of information off here. So the positive variable this time I can see that's x. So this is going to be a horizontal hyperbola. In fact, I can read the X intercepts off, plus minus 2. Okay, so those would be the vertices. Okay. I can tell you based on the fact that the x is the positive coefficient, this is horizontal hyperbola. What else can I do? Let's find the focus points. I use these numbers here, the sum. Plus minus root 13, so that's between 3 and 4. Just label. Put it between 3 and 4 and label. Okay, these are the foci, the asymptotes. So looking here again, so let's see. To draw my box, I use the plus minus 2s, those are here. Then I need plus minus 3s. That's how I get this box. It's here. Okay, the asymptotes go right through the corners of that box through the origin. Okay. And so let me see here. This one's too close to this one, I think. Move this down a little bit. Okay, so what is the slope? 1, 2, 3, right 2. So 3 halves. And this would be negative. So let me draw in the hyperbola. Something like that. Not too bad. And that's everything. There's one more, but they're all pretty much the same thing. Okay, so this one you just have to be careful because this one I actually have a number that's actually in the numerator. So when you go to find the x-intercepts this time, when you set y to 0, the equation actually looks like this. So actually the x-intercepts, or the vertices, are actually at a fraction. Plus or minus a half, 0. Of course, there are no y-intercepts because the y term is negative. And so we draw a graph. So I don't know how to scale. I mean, I can scale this in halves. Like we'll make this a half and this 1. Okay, so let's put the intercepts here, the vertices. Let me look at the focus points. So f squared is, so how do I do this? Be careful. So this equation, it's actually not written in standard form because I actually have to put that 4 in the bottom. So isn't multiplying by 4 the same as dividing by a 4th? Because I would flip and multiply. So actually when I'm looking to find my numbers for my focus equation, I'm actually looking at a quarter plus 1. So f squared is actually 5 quarters. So plus or minus root 5 over 2. So what is that? Root 4 is 2. It's a little bit bigger than 1, huh? So these guys are 0. Wrong axis. These guys are plus minus root 5 over 2, 0. And so those are like somewhere a little bit bigger than 1. Oops, that's a half. Be careful with the scale. Can label these. Root 5 over 2, 0. Negative root 5 over 2, 0. And this is, of course, a half, 0. Negative a half, 0. Okay, and then what about the asymptotes? So using these guys again. So let's see, the square root of a quarter was a half. So I went left and right by a half. The square root of 1 is 1. So I'll go up and down by 1 using that same scale. So it'll be 1, negative 1. Okay, something like that. Okay, so what color should I use? I'll use the blue, I guess. Here. And there, and then I didn't label the asymptotes, so let's see, the rise is 1, the run is a half, 1 over half is 2. Okay. Find the equation of the hyperbola centered at the origin with, I'll give you a minute to finish copying this here. Let's see. Okay, the vertices are on the y-axis, so I know my y squared is positive. I'll have minus. Let's see. So, I mean, I just have to put, let's see. So, the vertices are plus minus 6. This would have to be a 36. And then let's call this n squared. Okay, I know the asymptotes. So, how does this work? So, let me see here. If I was going to do a rough sketch. The rise is 3. The run is 1. One, 2, 3, 1, something like this. Okay, and then of course the same thing on the other side. Okay, and then it's the vertices are at 6. 1, 2, 3, 4, 5, way up here. So, oh, if I like the way I sketched this. Needed more room. I'm just trying to get a basic idea. So, I mean, it's going to look something like this. So, what I was trying to determine was the number that goes underneath the x. So, look, for my box, when I'm drawing my asymptotes, let's see, I would go up and down by 6. That would put me here. And then how far would I have to go left and right? Well, I'd have to go left and right by 2, right? In order to get to that asymptote. Like you see, when I go up and down, 1, 2, 3, 4, 5 by 6, I have to go left and right by 2. So wouldn't the number underneath here have to be a 4? Because look, y squared over 36 minus x squared over 4 equals 1. So how would I graph the asymptotes? I'd go up and down by 6, that's here, left and right by 2. That would give me the asymptotes that I have in this picture. What about something else? Find the equation. Let's see, here are the vertices. So this one's an x squared over 36 minus a y squared over n squared. Now this one, it gives you a point, an xy pair. So in this case, I would just plug the xy pair in and solve for the missing variable. Okay, so then 9 squared is 81. Divide by 9, 9/4. I have a couple of options for how to solve that. Maybe I multiply the whole equation by 4n squared, the LCD. Then I'd have 9n squared minus 100 equals 4n squared. Combine those like terms. So n squared is 25, and that's the information I needed, right? So x squared over 36 minus y squared over 25 equals 1.